Okay, group 2. Group 2, also known as the alkaline earth metals. So the elements in group 2, at the top of group 2, you've got beryllium, then magnesium, then calcium, then strontium, then barium, then radium. Okay. Now they're all group 2, so they all have 2 outer electrons, and so they all form +2 ions. Okay, because they're all group 2. So what do you need to know? So first, you need to know the reaction of the group 2 metals with oxygen. Reaction with oxygen first. Okay. Now the general equation is the group 2 metal. It's a metal, so it's a solid. It reacts with oxygen, which is a gas, to give a metal oxide. Now because it's metal +2, it'll form MO, because oxygen is -2, M is +2, so it'll be MO, and it'll be a solid metal oxide. We need to balance the equation. There are 2 O's, so we need to put a 2 there to give 2 O's, 2 M's, we need to put a 2M. So that's the general equation. Let's give a specific example of magnesium. Magnesium burns with a bright white flame. When you put it in a Bunsen burner, magnesium burns with a bright white flame. Okay, so in oxygen in a Bunsen burner, it will give you magnesium oxide, metal oxide. We need to balance it to 2. Okay, and then let's do the next one. Reaction with water. Reaction with water. I'm going to leave a little gap. Reaction with water. Reaction with water. And when you put a metal, group 2 metal, in water, group 2 metal in water, it forms metal hydroxide plus hydrogen gas, H2 gas plus hydrogen gas. And then we need to balance it. There are 2 hydrogens, there's 2 oxygens, we need to put a 2 there, 4 hydrogens, 4 hydrogens. Okay, let's give a specific example. Let's go calcium plus 2 waters gives calcium hydroxide, aqueous, plus hydrogen gas. Hydrogen goes around in 2s, it's a diatomic molecule. Okay, and then the last reaction you need to know is a reaction with acid. Reaction with acid, and any acid it can be. I'm just going to choose hydrochloric acid. If we take the group 2 metal, put it in hydrochloric acid, acids are always aqueous. That will give you the metal chloride in this example. Remember the M is 2+, and therefore Cl is 1-, and therefore there's 2 of them, plus hydrogen gas again, molecule of hydrogen gas. And then we just need to balance it. There are 2 Cl's, you need to put 2 there, 2 Cl's, 2 H's, 2 H's. Okay, now these are the 3 main reactions of group 2 metals. Reaction with oxygen, reaction with water, and reaction with acid. But what is actually happening in each reaction? So if we take the reaction with oxygen first, if we use oxidation numbers, okay, so we see that the oxidation state of magnesium, the oxidation number is 0. And what's the oxidation number of magnesium over here? Well, it's group 2, so it's +2. Okay, so magnesium has gone from 0 to +2. The oxidation number has increased, and that is oxidation. And then if you look at the oxygen oxidation number of oxygen, again, because it is an element, it is 0. The oxidation number of oxygen here is -2. Oxygen is always -2, except in the exceptions. And that oxidation number has reduced, and that is reduction. So this is an example of a redox reaction, because the magnesium has been oxidized and the oxygen has been reduced. If we were to write the half equations, because this is the overall equation, what if we were to write the half equations showing what is happening to magnesium and what is happening to oxygen? Now magnesium is becoming Mg2+. Okay, now to become an Mg2+, we need 2 electrons. And can you see the total charge on the right is 0 charge. The total charge on the left is 0 charge, so that matches. The magnesium has lost the electrons, so that is oxidation. And then let's focus on the oxygen here. So the oxygen has gone from an oxygen molecule to 2 oxide ions. Total charge 4 minus. So over here we need 4 minus. The oxygen has gained electrons. Remember that we're dealing with oil rig. Oxidation is the loss of electrons, reduction is the gain of electrons, and that is reduction. And that is what is happening when you react with oxygen. Magnesium is oxidized and the oxygen is reduced. And it is the same with water. If you do exactly the same with water, what's the oxidation state of calcium? 0, because it's an element. What's the oxidation state of calcium here? +2, because it's in group 2. And that is oxidation, because the oxidation number has increased. Oxidation of hydrogen, because it's an element, it is 0. Oxidation number of hydrogen here, well, oxygen is -2, therefore each hydrogen must be +1. So it's gone from +1 to 0. The oxidation number has reduced, so that is reduction. So again, reaction with water is a redox reaction. Finally, the reaction with acid. So if we take whatever the metal, group 2 metal is, it's an element, its oxidation number is 0. Over here, Cl is -1, and there are 2 of them, oxidation number. So metal is +2 because it's in group 2. That is oxidation, because the oxidation number has increased. Hydrogen is an element, has an oxidation number 0. H here, Cl is -1, H is +1. Remember, it's nothing to do with the number at the front. The oxidation number +1 to 0, is a reduction. So that is a redox reaction. Okay, so all these 3 examples, reaction with oxygen is redox, reaction with water is redox, reaction with acid is redox of group 2 metals. Now in each of these examples, how is magnesium actually reacting? Magnesium is being oxidized. Okay, magnesium is losing electrons. Magnesium is the oxygen is being reduced. I'm going to just do a new piece of paper just to make this clear. Okay, so I'm going to take the first example, but it's the same for all of them. Okay, all right. So in this first example, just take magnesium. It can be any group 2 metal. Okay, in this example, oxygen, okay, is going from oxidation state 0 to oxidation state -2. Okay, the oxygen is being reduced. Okay, the oxygen is gaining electrons. Each O is gaining 2 electrons to form 2 oxide ions. Okay, the oxygen is being reduced. Therefore, magnesium is a reducing agent, because it's an agent to help something be reduced. A bit like an estate agent. An estate agent helps somebody sell their house, helps somebody buy a house. Reducing agent helps something be reduced. So oxygen gains electrons, magnesium gives away its electrons so that oxygen can gain them. Magnesium gives them away so that oxygen can gain the electrons. So group 2 elements act as reducing agents. Okay, a reducing agent is itself oxidized. It's not reduced, it's helping something else be reduced, is itself oxidized. Okay, so we need to know the trend, what is actually happening here. So those are the 3 key reactions: reaction with oxygen, reaction with water, reaction with acid. But what happens as you go down the group? Okay, so going down the group, we've got beryllium at the top, we've got radium at the bottom. Okay, what happens in terms of reactivity as you go down the group? Now, if you think about it, all the metals are forming a 2+ ion. They are losing 2 electrons. So as you go down the group, is it easier to lose 2 electrons, or is it harder to lose 2 electrons? Well, as you go down the group, the atoms are getting larger. The atoms are getting larger. The atomic radius increases. As you go down the group, there's more electrons, more shells. As you go down the group, there's more shielding, electron shielding. That's the repulsion of the inner electrons on the outer electrons. So as you go down the group, there is decreased, less nuclear attraction for the outer electrons. Nuclear attraction between the nucleus and the outer electrons. So that's what's happening as you're going down the group. So what happens to the reactivity of the group 2 metal as you go down the group? It is easier to lose electrons. So they become more reactive down the bottom. That's the most reactive, that's the least reactive. Okay, so reactivity increases down the group. Okay, similarly, okay, so what about the reducing agent? Which is the best reducing agent? Which is the best one, the strongest reducing agent that will be oxidized the easiest? So again, this is the most reactive down the bottom, and this is the strongest reducing agent. It's the strongest reducing agent because it loses its electrons the easiest. Okay, loses electrons the easiest. Okay, finally, we need to know the trend in ionization energy. Okay, so it's very similar. So in order to form a 2+ ion, okay, that's happening in steps. So first, if you look at ionization energy, the metal in the gaseous state loses the first electron, and that's first ionization energy, and then it loses a second electron to give not 2 electrons, pardon me, sorry, loses an electron, and to give the 2+ ion, it's 1 electron, it's not 2 electrons. That's the first ionization energy, that's the second ionization energy. What happens with ionization energy as you go down the group? As you go down the group, the ionization energy decreases because less energy is needed to remove an electron because the atoms are getting larger, the atomic radius, there's more shells, more shielding, less nuclear attraction. The outer electrons have less attraction to the nucleus, so the ionization energy decreases. Okay, so that's the trends. Ionization energy decreases, you go down, reactivity increases, and the reducing agents become stronger down the bottom. Okay, the last bit we need to know is about the group 2 compounds. So the group 2 compounds. So let's take group 2 oxides first. You need to know about the solubility of group 2 oxides. Okay, so let's just write an equation first, just to show it in what happens. So if you have calcium oxide, for example, and you add it to water, and it forms calcium hydroxide, aqueous. And then we just need to balance it. 2 oxygens, 2 oxygens, 2 hydrogens. Okay, it's already balanced. Now what happens when you have a group 2? So a group 2 oxide forms calcium hydroxide, a group 2 hydroxide. Now in water, this is an ionic compound, and in water it splits up into ions, calcium ions and hydroxide ions. Okay, but there's 2 hydroxide ions because there's 2 there, right? Hydroxide ions are alkaline. That means they've got a pH greater than 7. Okay, so remember, acids are pH 1 to 7. 7 is neutral. Above 7 is alkaline, and hydroxide is an alkali. Okay, now you need to know the trend down the group 2 hydroxides. If we take magnesium hydroxide, calcium hydroxide, strontium hydroxide, just the middle ones, barium hydroxide, okay, what's the trend in solubility? Okay, as you go down the metal hydroxides, solubility increases. Okay, so that means this barium hydroxide is more soluble in water than magnesium hydroxide, okay, which is the least soluble. Right, so when this reaction happens with water, with magnesium hydroxide, okay, you will get, it's not very soluble. It's a little bit soluble, but it's not very soluble. Okay, so if this magnesium hydroxide is the least soluble, okay, that means it does not release many hydroxide ions. It means it's got a low concentration of hydroxide ions, okay, because it's not very soluble. So therefore the pH will be quite low. It's still an alkali, but it'll be lower, so it'll be about 10. Whereas barium hydroxide is a lot more soluble, so it will release, barium hydroxide will release more hydroxide ions. There'll be a higher concentration of hydroxide ions, and therefore the pH will be higher. I don't know, maybe about 13, something like that. Okay, so just to remember with the pH scale, if you've got pH scale 7 is neutral. If you've got like pH 1 over here, pH 1, that means there's a lot of hydrogen ions. The concentration, square brackets means concentration. The concentration of the hydrogen ions is great. If you have 14, that means the concentration of the hydroxide ions is high. So that's high there of hydrogen ions and high of hydroxide ions. Square brackets in chemistry means concentration. Okay, and why the solubility increases? You don't actually need to know, but it's due to the very small, highly charged magnesium ion. Okay, the last bit you need to know is the uses of group 2 compounds. The uses of group 2 compounds. So the main uses of group 2 compounds. So this could be a 1 or 2 mark question. Not group 2 metals, of group 2 compounds. So one of the main uses is in agriculture. In farming. Okay. Group 2 compounds are used. Group 2 compounds are used to neutralize acidic soil. So it puts it on the soil to make it less acidic. Okay. So if you take calcium hydroxide, which is lime, solid, it's a white powder, and it gets sprinkled onto the soil. You might see the white on the soil, gets sprinkled onto the soil, reacts with the acid, whatever the acid is, H+, and it releases calcium ions and water. So there is less acid, removes the acid from the soil, it neutralizes acidic soil. Okay, that's one of the uses of group 2 compounds. Another major use is in medicines. Okay, so for example, it's used, group 2 compounds are used to treat acid indigestion, to neutralize acid in the stomach. Okay, so it's used as, they're called antacids. Okay, for treating indigestion, for treating acid indigestion. Okay, so for example, well-known example is magnesium hydroxide, which can treat the acid in the stomach, to give magnesium chloride, to give a salt, plus 2 waters. Okay, also it could either be magnesium hydroxide in the medicine, or it could be calcium carbonate or magnesium carbonate as well. And they all neutralize the acid in the stomach. Calcium chloride, oh sorry, not solid, I'm sorry, this is not solid, that's aqueous, it's a salt. That's aqueous because it's a salt. Plus, what else have we got? Plus water, plus CO2 gas. Okay, calcium chloride is a salt, magnesium chloride is a salt, so therefore aqueous.